Lesson 322, Area Under a Curve, Part 1. Today you're going to estimate the area under a curve and understand that area under a velocity curve represents distance. So you've worked with area on lots of different shapes, but today we're going to work on investigating area under a curve using those familiar shapes. In order to record your information today, you need to open this link in Desmos. So you want to find lesson 322 in Desmos. And then you're going to record your answers to the lesson on those slides. So, problem 101. Aaron drove from Green Bay to Milwaukee. So read through this problem and sketch a neat and accurate graph of the situation. And you're going to draw your graph in Desmos. First slide in Desmos is your energy level over the past couple of weeks. Since we've had holiday break, hopefully your energy level has increased and you're ready to get this semester finished. Second slide in Desmos is where I want you to make your graph of Aaron's situation. It said for the first half hour, she drove at a constant speed of 25 miles per hour. And then she was gradually able to increase her speed at a constant rate until she reached a speed of 75 miles per hour, a quarter of an hour later. So after a quarter of an hour passed, she was able to increase her speed to 75 miles an hour. And then she continued at 75 miles per hour for a total of 2 hours of driving. So that's what your graph should look like in Desmos. And we're comparing the time in hours to her speed in miles per hour. So what are the units when calculating the area of the shaded region? If I want to find the area under this curve, so the area of this shape, area is equal to length times width. So I'm multiplying the time in hours times the miles per hour which gives me an area in miles. So the area under the curve represents the number of miles she traveled. So to calculate this area of the shaded region, I can break my shape into different pieces. So I'm going to have 2 rectangles and a trapezoid. Area of the first rectangle is 0.5 times 25. Area of the second rectangle, my base is 1.5 times a height of 25. And the area of the third shape, my trapezoid, is 1/2 times the sum of base 1 plus base 2 times the height. To get a sum of 118.75, which represents the number of miles she traveled. So what does the area from 0.5 to 0.75 represent in the context of this problem? So this section of the graph right here represents the distance she traveled while accelerating. So looking at the math notes in your book and looking at the area under a curve, we have some new math notation. So this is the area under the curve over a certain interval. So if I want to find the area of this function between the intervals of 1 and 3, I would write it like this. So area, and then the function that I'm evaluating, and then the interval that you're evaluating the area for. So I want you to read through these math notes and in your own words, answer these questions in Desmos. Moving on to problem 102. I'm going to evaluate the function 9 minus 2x. And I want to find the area under that curve for the interval between 1 and 3. So in Desmos, we're going to sketch that curve. So again, the function that we're evaluating, that we're sketching, is the function f of x is equal to 9 minus 2 to the x power. And I'm looking at this only between the intervals of 1 and 3. So I'm looking for this area under the curve. And if I want to figure out how I can approximate that area, I have to think about what kind of shape I might want to put in. So if I look at this, it looks somewhat like a triangle. So if I want to treat this like a triangle, one option to find the area of this shape is to do 1/2 times the base times the height. Which would give me approximately an area of 7. Another option that I could have is to divide that into a trapezoid and a triangle. So if I look at this area and I make a trapezoid, I'm getting much closer. So that's one shape under my curve. And then I could go and make a triangle. And I could add the area of those shapes together. So finding the area of my trapezoid, 1/2 times the sum of the base 1 plus base 2 times the height, plus the area of my triangle, 1/2 times the base times the height. I would have an area of approximately 7.5 square units. So I could continue to draw smaller and smaller shapes to find the area under that curve. Moving on to problem 103, I'm going to add this function onto the problem from 102. So I have my original curve, and now I want to graph this radical function, square root of x minus 2, over the interval between 3 and 6. So finding this area and adding it into Desmos. Looking at the area under this curve. Finding that area, I could look at all of my rectangles that are inside here. So break this into tiny little rectangles. And add up all of the rectangles. So I want you to approximate the area. So look at how many rectangles you could make in this shape. Find the area of each rectangle, add them up, and put your answer into Desmos. I'm thinking you should probably have something in between 4 and 5 square units. Homework for this section is problems 106 to 113. You can skip problems 108 and 110 and bring your questions back to class the next time I see you. Have a good night.